Alright, in this video we're going to be talking about parts of expressions, which will lead us to parts of equations, since expressions help make up equations. So first you have to know the basics, and we've talked about this a little bit already, but an expression is a statement in math that has no equal sign, and an equation is a statement that has an equal sign. So if you look, 3x plus 7 right here does not have an equal sign, so that's why I've drawn an arrow from expression. That would be an example of an expression. But down here, we still have 3x plus 7, but we've included this equal sign now and added a 2 at the end, which makes it an equation now. So an expression can turn into an equation simply by just adding an equal sign and something else on the other side of the equal sign. So with that being said, parts of an expression, you have coefficients. Coefficients are the numbers in front of a variable, and also a number being multiplied by a variable. So for instance, if I want to give you a few examples, I can say 2x. That's an expression. There's no equal sign. So a coefficient for this would be the 2. So 2 here is in front of the variable, which is one way we defined it. And it's also being multiplied by the variables, because this really means 2 times x. There's an understood multiplication going on there. So 2 would be your coefficient. If you had another example, maybe you had 3xy plus 4z. You've got 2 coefficients now because you have 2 numbers that appear before variables and that are being multiplied. So on this side, you have 3 times xy. Over here, you have 4 times z. So they're both in front of variables. They're both being multiplied by a variable. So in this case, you have 2 coefficients. It's 4 and 3. Now, be careful. Every time we do this, I always see people that if I, for instance, give you something that looks like this, if I give you a problem on an assessment and it says find the coefficients, and I give you 2x plus 3y equals 7. Let's talk about lines. I always have people that say the answer is 2x and 3y, that those are the coefficients. Look at the definition. The definition doesn't include the variable. The definition says we're looking for the number in front of the variable and being multiplied by the variable. So if you give me 2x and 3y for this example, you're wrong. All right? The actual answers are just the number. So just 2 and just 3. That would be your solution. So be careful that when you're asked for coefficients that you're not adding more than what you need. You don't need the letter, you just need the number in front. All right, so that's very important. A variable is an unknown value, and it usually is represented by a letter. So for instance, again, we've been already throwing these in here. I could give you something like this. So x is an unknown value. I have no idea what it is right now. It could be anything. But if I add an equal sign, 2x equals 4, we already know how to solve equations. So in this case, x represents a specific value. It's an unknown because it's a variable, but we can go find what it actually is to where it's not unknown anymore by simply just solving like we know how to do and finding here that x equals 2. So 2 has a specific value in an equation. Now, if we don't have an equation and we just keep it an expression, let's say 3xy plus 4z again. Right now, x, y, and z are all 3 variables. So if on an assessment it says list the variables here are x, y, and z. There's 3 of them. Alright, so I'm not worried about the coefficients this time. I'm worried about just the letters. Alright, but be sure if you have an equation that you actually know that there is a value for those variables. We actually have a number that we could go and figure out for those. So right now, though, with it just being an expression right here, we cannot go do that. It could represent anything. Now, one thing I want to point out, a lot of you fall into the trap of thinking, if I give you something like this, because we're about to start studying this, if I say 2x plus 4 equals 7 maybe, some random equation, for some reason a lot of people like to give this as an answer, always, x equals 1. And I'm not sure where this came from, this idea of x always being 1, because there's always at least a few people arguing that somewhere along the line in their education, 1 is the value of x. And I'm not sure where that comes from. Now, I think maybe it's because once you solve for x, maybe we solved an equation and we get x equals 4. The coefficient in front of x here is an imaginary 1. So the coefficient on x is 1, but the actual x value is 4. So be careful that you're not falling into that trap of x always being equal to 1. The coefficient is when you're solving, all right, but right now the coefficient's 2. So x does not always have a set value, and it's not always 1, so be careful with that. A term is any piece of an expression that is separated by a plus or a minus sign. So, for instance, and this is pretty easy to pick out, one thing they could ask you is maybe what are the terms, or they could say how many terms are there in this expression. So let's say I have 2x plus 3y minus z. Well, if you will go identify your pluses and your minus signs, that's going to help you a lot. So there's a plus, there's a minus. And we said that terms are the things that those separate. So right here is a term, here's a term, and here's a term. So we have 3 terms here. And those are 2x, 3y, and z. So if they ask you for what the terms are, you have 3 of them here, and they're separated by the plus or the minus sign. So another example maybe would be 2x plus 1 minus 3. Here, we only have 2 terms. Now some of you are like, well, there's a plus and a minus, and I agree with you, there's a plus and a minus. But what you need to consider is this whole thing is attached because it's 2 times that whole quantity. So this whole thing is 1 term, this 3 is another term. So right now you've just got 2 terms. Alright, now if I were to go distribute and get 2x plus 2 minus 3, now I can see your valid argument. There's a plus, there's a minus, and there's 3 things. So we just turned it into a 3-term expression instead of a 2. But if you don't distribute here at this step, there is only 2 terms. So make sure you're being careful. Alright, now factors. In elementary school, you were taught that 2 things that multiplied together were factors. So 2 times 2 equals 4. If I gave you some statement like that, you were taught that these 2 things were factors, which is true. We're just going to start talking about it in terms of expressions and equations now. So same idea though, 2 things that are being multiplied, and it could be a number, a variable, or an expression now for us. So I could give you this, and 2 and x are your factors. So you've got 2 as a factor and x as a factor. They're being multiplied together. So both of those are factors. I could give you x plus 1 and x minus 2. You have 2 factors, and if you notice, this whole thing is being multiplied by this whole thing based on our parentheses here. We've got a little understood multiplication sign. So there are 2 factors still here, even though there looks like there's 4 different things going on with the x, the 1, the x, and the negative 2. So here we have 2 as well, just like we did up here. Let's try another one. Let's say I give you something a little more ugly looking. I give you 2x minus 1 plus 4. Now, a lot of y'all are going to be tempted to say that there's 2 factors here because you have 2 being multiplied by x minus 1. While I agree with you partly, we need to talk about why it's not totally true here. So, if we were to ignore this 4 for a minute, and just imagine he's not there, and this was the only thing. I agree that the 2 is being multiplied by the x minus 1, the whole quantity, so that would be 2 factors. However, we have the whole thing, 2x minus 1, being added to 4. So right now, the understood operation, the overlying operation in this expression is the addition. We've got this whole thing plus 4. So right now, there are no factors in this whole expression, but if you break it down and say, like we were talking about before, maybe we're just looking at the first term in the expression, then we have factors. But if I give you something that looks like this and ask you what the factors are, that's kind of like a trick question, honestly. There are no factors as it stands here. But now if I say, what are the factors of 3 times x minus 1, you can give me those, 3 and then x minus 1. So be careful when you're talking factors that you're not including more than you need to. So here's your practice, and like always, I'm going to ask you to pause the video and try these and not cheat. So I want you to identify all coefficients, terms, variables, and factors in each of the following. So there's 4 examples. Write them down somewhere on some scratch paper. Pause your video at this point and unpause me when you are ready to have the answers. Alright, so now that you are ready for the answers, let's talk about it. And it's going to get a little busy on this screen, so I apologize. But for the first one, coefficients, you should only have 3. 3 is the only number here in front of a variable, so 3 is a coefficient. All right. If we want to talk about terms, there is only one term here because if you notice, there is no plus or minus anywhere in this expression. So there is only one term, and the term is this whole thing, 3x, y, z. I'm going to try to color code things for us. All right, so let me go back real quick. Coefficients I'm going to do in red. Terms I'm going to do in green, and let's pick blue for variables, and we'll pick another color for factors. So let's look at variables in number 1. We've got 3 variables. We've got x, we've got y, and we've got z. So 3 different variables here. And then let's change the color real quick. Let's see. Something different. Let's do yellow. All right, so yellow is going to be our factors. So factors here, there's actually 4. We've got 3 times x times y times z. So all 4 of those have an understood multiplication symbol in between them. So there's actually 4 factors there. All right, let's look at number 2. Let's go back to coefficients. So coefficients here, again, are the numbers in front of your variables. So you've got this, -2, and you've got 4. And then you've got to consider your terms. So your terms here are, again, anything separated by a plus or a minus. So you see that big minus sign here again. So this is one whole term, and this is one whole term. So you only have 2 terms. And again, this is like that other example. If I were to go distribute, I'd turn it into more than that. But right now, as it stands, we only have 2 terms. All right, variables. I have, again, x, y, and z. So those are easy to spot, any letters. And then factors. This is one of those trick questions. As it stands, let me rewrite what we had. 4x plus y minus 2z. As it stands right now, this whole underlying problem is looking at subtraction. So if I were to ask you what the factors are, there are not factors in this whole problem. But if I were to ask you maybe what the factors of this piece is, you could say 4 is 1 and then x plus y is 1. And also, if you look at this back piece alone by itself, 2 is a factor and z is a factor. But all together in this problem, since it's an overlying subtraction problem, there is not a big factor lying around in there. All right, so be careful. Number 3, coefficients. I've got 4 and 2. All right, now 7 is something we like to call a constant, and we didn't really talk about that. But a constant is a number without a variable. All right, so a number with no variable. So he stands alone by himself. So he's a constant. If I look at terms here, terms, you've got 4x, 2y, and 7. So there's 3 terms separated by the plus and the minus. And then you've got to look at your variables. So any letters you see, so x and y. And then if you look at your factors here again, there is no overlying factor because we're adding and we're subtracting. But if I were to look at maybe this piece by itself and this piece by itself, we could call those factors of each other. So let's jump down to the last one. Coefficients, we've got 4. And then we've got some understood stuff going on we hadn't talked about too much. But if you see a variable without a number in front, it's understood to be 1. But we're not really going to call those coefficients since we know that they're there. All right, so 4 is our coefficient here. If I look at terms, we've got one whole term. That is all one whole term, believe it or not. So in between the 4t and the x minus 2 and then the x minus 2 and the y plus 1, those are multiplication signs. So there is no adding or subtracting anywhere in here. Even though inside the parentheses it looks like it, that's one whole term, and we have to call it that. So be careful with this. That's one whole multiplication term. All right. Then for your variables. Variables here, easy to spot again. You got the t, the x, and the y, any letters. And then our multiplication. Now we got some factors to talk about. We've got 4t, x minus 2, and y plus 1. So those 3 things are being multiplied together. Remember, there's multiplication in between here. So we have 3 factors. All right, and if we want to list them, we've got 4t, it's just the pieces, x minus 2, and then y plus 1. Those are our 3 factors because they're all being multiplied together. And there's no other subtraction or addition in the problem that we have to worry about. So there's your practice. If you got any questions, let me know. And until next time, keep practicing.